So please join me in welcoming Dr. Jan Minx to the stage.
Thank you, Hannes, and thank you everybody from Carbon Futures for really having this event and bringing this on. I think it's a great opportunity. Personally, as a scientist, I'm a little bit scared because so much energy in the room is almost too much for me. So it's hard to cope with that, but I'll give my best. Yeah, what I would like to do today is to talk a little bit about a report we brought out in January on the state of carbon dioxide removal. And that's working a little bit differently than I thought. Yeah, so why did we do that? Because in some sense, our feeling was carbon dioxide removal is a little bit like the renewables in the 1990s. So, you know, where there was a lot of dynamic, we can see dynamic, you know, in the industry, lots of action going on. But then, on the other hand, there's still so many things that are unresolved. There are fundamental knowledge gaps still. There is not sufficient attention in policy, and there are also major data gaps. So there are, you know, fundamental questions like how much carbon dioxide removal is there actually today, something that is still an unresolved question. We try to provide an estimate, but I wouldn't claim that that's the final answer. As scientists, of course, we started off by defining CDR, and that's probably not new for you, but let me quickly summarize it here. So for us, it's basically important if we talk about carbon dioxide removal to make sure that we follow three principles. The CDR must be captured from the atmosphere. It needs to be durably stored, and we are a little bit vague what that means. We are scientists. And then it also needs to be additional to natural processes. That's actually important for the quantification of how much carbon dioxide removal there's actually going on today. We also thought about clustering different carbon dioxide removal methods that are out there. And often, you know, you have this distinction between natural CDR and technological CDR. And we felt that's not a good distinction because is it technological or is it natural? What about biochar? Is that natural? Is that technological? So we thought, okay, let's try something else. So we said, okay, there are some technologies or methods that have been applied for longer periods of time, further down the TRLs, and we called them conventional CDR on land, so soil carbon sequestration, afforestation, wood in construction, etc. And this is, you know, where most of CDR today is coming from. And then there are a whole lot of other CDR methods, which we call novel CDR, which, you know, basically bundles all the other ones. So that's just as the background, because I think that distinction is also helpful if we start to look also into some of the data that has been provided from modeling teams in climate change mitigation scenarios in the IPCC, and it's helpful actually to contextualize a little bit what we see in that data. So I want to try to answer a few questions here, and I start with a very basic one. So what is the role of CDR in climate change mitigation? And I think there are two fundamental things that we want to do with CDR. On the one hand, we want to compensate really hard to abate residual emissions. It's easiest to think of in the context of carbon neutrality or climate neutrality. There will be some processes that are really hard to abate, and those we will need to compensate with CDR. But then there is also a second important role that we also see in almost all scenarios that are basically able to limit global warming to well below 2 degrees C, and that is creating net negative emissions. So actually removing actively carbon dioxide overall from the atmosphere after a while. And that is actually the reality when politicians, people talk about the 1.5 degree world, because essentially there are hardly any scenarios left that can limit global warming to below 1.5 degree without pulling back temperatures a tiny bit in the second half of the 21st century. And that is basically achieved via net negative emissions. And if we think beyond that, if we have that capability, I think from all that we know about climate impacts, that we will maybe not be happy with 1.5 or 1.7 degree, and we may want to clean up our atmosphere. Here is a chart that you typically see in the IPCC, which shows you a net emission pathways in 1.5 and 2 degree scenarios. And the big message here is CDR is not something that we can do, it is something that we must do. And if we want to understand how mitigation evolves over time, then it's really helpful to actually cut that chart into two halves. In the first half of the 21st century, it's all about reducing emissions. If we want to, basically achieve, like in 1.5 scenarios, climate carbon neutrality by mid-century, then we will first of all need to cut emissions down a lot. But what many people completely overlook is to look at that. And I think that's really, really useful to do, because in the second half of the 21st century, actually mitigation is mainly about carbon dioxide removal in both 1.5 and 2 degrees world. And this is something very few people are talking about, but it's really important. And if that's the case, we will probably already need to do a lot today to enable that to happen. I promised you to give you a first answer to this question. It's certainly not a final answer. We are scientists, so there will be hundreds of more answers, but we will converge towards something and improve over time. So how much CDR is there today? We did a quantification, and our estimate is that current CDR is around 2 gigatons per year. That's about 5% of current CO2 emissions globally. And the interesting thing about this is that 99.9% of that is that gray bar, that's conventional CDR on land. That tiny, tiny bit there, it's actually 2 million tons, that's novel CDR. So it's 0.1% overall. So basically the message here is, yes, CDR is already happening today, but novel CDR is still really at its infancy, and we need to do something about it, and we need to scale it. And why we need to scale it, I will also show you in some slides later on. But we are really at the very beginning, and we must spend more attention to developing novel CDR. How much CDR is used in scenarios that meet the Paris climate goals? I'm always very nervous about specific numbers when it comes to those scenarios, but I still think looking at the big picture is quite good. So that's the range of CDR that you can see in 1.5 and 2 degree scenarios, and you see that this goes from roughly current levels down to 10, 12 additional gigatons by mid-century only. That continues, that is further scaled later on. To keep things simple, we basically chose 3 focus scenarios in the report. One that basically emphasizes a little bit demand reductions, one focuses on renewables, and the other one focusing on carbon dioxide removal. In general, it's very important to understand that scenarios that are up there that really limit CDR are very aggressive in reducing CO2 emissions, and are very successful. So any year we are still growing emissions, and we are still in a world of growing emissions, means that we have to do more CDR later on. So we are growing our dependence on CDR. And those scenarios, so for example, the focus on demand reduction scenarios has already 48% net greenhouse gas reductions by 2030, just to give you an impression, by 2030 from 2020 levels. So we are still not doing this today, and we have 7 years left. So just to give you an idea, but also the others have basically still are cutting still emissions by a third, and we are not anywhere near. So attention to reducing emissions is important, but we also need to spend attention on growing CDR. This is the promised slide where I told you why novel CDR is so important. It basically shows you what scenarios show on the one hand in terms of development of conventional CDR on land for 1.5 and 2 degrees scenarios, and on the right-hand side for novel CDR. And there you can see that what we find in the models is that conventional CDR on land is quite limited in terms of scaling. You can scale it, but not so massively. So we need, this is not to say that this is not important, we need to do this as well, but we also really need to invest in terms of into new technologies, novel CDR that scale CDR. Are we on track? I think you know the answer, but I still do it. So what we did is that we analyzed what countries are pledging in their national determined contributions. So basically their emission reduction pledges under the United Nations Framework Convention on Climate Change, and also in their long-term strategies. And what we find is, first of all, that in both in the NDCs and in the long-term strategies, we don't see a substantial scaling. In terms of the NDCs, so the near-term goals, it's quite stunning that there is not a single country today that pledges any novel CDR in their NDCs. In terms of the long-term strategy, we need to caveat, because that data is very incomplete, because parties in the UNFCCC are not obliged to report long-term strategies, so we don't have long-term strategies for all countries. There are some countries, like the US, that have not unambitious plans for CDR. So that's really an underestimate. But it's the best we have. And so we took it and compared it what we see in, and compared it with the scenarios. And here only the 3 focus scenarios. Again, remember, they are particularly at the higher end. They are not extreme scenarios. We deliberately chose not to pick the most extreme scenarios, but we see in the short term and in the long term a substantial CDR gap for all focus scenarios. So even on the focus on demand reductions with the 50% emission reductions by 2030, even there we are seeing a gap in the short and in the long term. So this is really something that we need to that we need to address. So maybe an intermediate wrap-up of this is that any robust strategy for meeting the Paris temperature goal is to limit the dependence on CDR through rapid and deep emissions reductions. This is something that we really have to do. We have no chance to reach carbon neutrality, at least I believe that, unless we do this. So that's really important. It's the 2 things cannot be contradictions. We need at the same time aggressively develop and scale particularly novel CDR, but not only. Of course, we also need to take care of conventional CDR on land. So both of these things are really important. I want to close by looking a little bit at the innovation dynamics And that's something where the report made the first attempt. We want to develop that a lot in the future, but I can give you some initial kind of results and thoughts. So we try to measure growth and innovation, and if we do this, I think it's really important to take a systems perspective on innovation. Innovation is not only R&D. Innovation is also basically building demonstrators, scaling up, and then also about so-called demand factors like niche markets, like demand pull that includes policies, and also about the response by the public. We know that from the CCS discussion in Germany, for example, where everything at the end of the day came to a halt. And if we want to learn about innovation, we need to learn about all those steps and put indicators against those. We basically only characterized innovations by three indicators: public R&D spending, patents, and then also investments in additional capacities. And the big message of this all is that innovation has developed, particularly in recent years, quite rapidly, and so we are really seeing a dynamic growth. And I will show this for patents that are a measure for the inventive activity. And if you look at the top chart, then you can see that over the past 2 decades, patenting activity increased substantially. The 2 last years are truncated because patents take time to be reviewed and so on, so the data is still incomplete. That's important to consider. The second big message is, in terms of the regional breakdown, is really that we have a lot of patenting activity from China, particularly in the last 2 years, but that's probably due to the way the patents are processed. But that's something we do not know for sure. But overall, also in the other years, China has significant share. And in terms of technology, it's really that we see a lot of, even over time, a lot like direct air capture has the largest technology share in tech, but over time, that's nice to see that the portfolio is diversifying, the portfolio of patents. And so that's a good sign. Last content slide on the future growth So we've looked at, what are countries planning? And, we saw, okay, maybe not enough. We need to become more ambitious on that end. But we also looked at, what we can infer from company and industry targets. And those imply much faster growth. So here, the squares are the current deployments. The circles are basically are targets. And the gray shaded area is basically what we see, what has been indicated as a range for sustainable potential for this CDR method. We basically open that range from the last point where we have company data. And the big message here is really that companies and industry are much more in line in their plans with what is required for meeting the Paris Agreement. And I think overall that is really good news. But at the same time, those growth patterns that we see there are really ambitious. So on average, about 50% if you take the higher end of the 2050 range, if we want to get there. And that basically would mean that faster growth that we have seen for most other historical technologies. And that may not worry us too much for, some of the more granular CDR technologies, but for others that, involve large infrastructures. You know, we might be a bit more pessimistic on how to do this unless we really have a dedicated effort among industry and policy in that space. From our perspective, if we want to accelerate, and I think that's what this meeting is about, then it's all about the next 10 years. Science shows us that the formative phase, the point where we come to the first really large-scale industrial applications, is really critical to basically, and that determines very much what is achievable in the long term. So the formative phase for CDR needs to start now, and we need to really see that we get deployment on the ground. Key messages: current CDR is 2 gigatons, almost all from conventional CDR. With novel CDR, we are at the beginning, but we need to scale. In terms of, we have a gap proposed between what is proposed by countries and what we see in the scientific literature. The more we grow emissions, and we are still at an emission growth, the more we will need to scale. And so entering a period of sustained emission reductions is important as well. But closing this gap also requires substantial new development of particularly novel CDR in the next 10 years. So the State of CDR was basically initiated by MCC, the University of Oxford, the University of Wisconsin-Madison, YASA, and SWP. We were very lucky to receive funding from some of our projects that we had already from UKRI, the ERC, the German Ministry for Research and Education, but also important contributions from Carbon Gap and Bank of America. And that's all for today. Thanks so much.